Welcome back to question number 3. And this question says complete each model to make like unit, right? You're going to complete each model, right? This model 1 and this is one model 2, right? So on the first one, it says complete each model to make like unit, right? The next one it says add or subtract. And the next one it says each tape diagram represents, you want to know what it represents, right? So to solve this problem is very easy, right? For you have to understand this word like unit, right? It's seen as well like fraction, right? So you have to make this fraction very same, right? So if here is 8, you have to make here 8, right? So you have to make the denominator to be the what? Same. We can solve this on a rough topic, like you can say uh 3 over 4 plus 1 over what? 8, right? Um, if I want to make this particular number at the bottom to be the same, then it means that I have to multiply here by 2, numerator and denominator, right? Because what affects down also it will also what affects up, right? So that means I can say 2 multiplied by the entire fraction, the first fraction which is 3 over 4 plus 1 over 8, right? Now if I take this let's hold on factor constant that this 2 is multiplying by everything in here, right? So we say 2 times 3 is what? 6. Divided by, we say 2 times 4 is what? 8 plus 1 upon what? 8, right? We're taking 2, we multiply by everything in here, multiply by up and multiply by what? Down, right? We take this 2, multiply by here. So we're taking 2 and multiply by the numerator and take 2 and multiply by what? The denominator, right? So if you multiply 2 times 3, you get 6. 2 times 4 is going to give what? 8, right? So we have 8 and 8, right? We have this common denominator will be the same. You observing it, right? The least common denominator is the same. So the rule says once the least common denominator is the same, we take 1 and we add or subtract the power, right? So we observing that since we have addition here, then that means we have to add the power, right? So we say 6 plus 1 is going to give us what? 7, right? So 7 will be your answer for this particular, sorry, 7 or 8 will be your answer for the particular problem. Now to rewrite in this blank, it is same as saying 6 over 8 here, 6 upon 8, and the next one is same as saying 1 over 8, right? 1 upon 8. So we have 1 to 1 upon 8. Now your answer, your final answer here is what? 7 upon what? 8. So this is your answer for this particular problem. Now to analyze the tape diagram here, because the question says each tape diagram represents, so we want to know the representation of the diagram, right? What it represents, right? Now we're observing that this diagram, um this tape diagram represents fraction. This is the first thing that we know, right? This entire diagram represents a what? Or fraction. When we see this diagram, what comes to our mind is what? Fraction, right? Now the next thing that comes to our mind, we say the denominator 3 is this 3 now, right? That's already numerator, right? This 3 that up here is already the numerator, right? So this numerator 3, it represents the shaded parts, right? So these shaded parts, it represent what? 3. So we have 3 shaded parts. 1, 2, 3. So it represents this 3 up here, right? So the numerator represents the shaded parts. Now, the number that I refer to as what? The denominator, right? So the denominator 4 represent the total number of the error parts, right? The total number of the equal part, right? In the whole, right? The whole meaning entire diagram. So this entire diagram represented as what? 4, right? So we have how many spaces here? 1, 2, 3, 4. That's why I say the denominator 4 represent the total number of the equal part. So all the total number of the equal part represent what? 4, right? So that is for our question 3. Now we move on to question. So we're not going to solve this problem the same way, but this time around we are dealing with subtraction, right? So we solve it like this. We say 1 upon 2 minus 1 upon 4, right? So the same way, we want to change this to 4, so that we can get 4 under here, so that the denominator can be the same. So in my next question, I will say 2 divided by 2 multiplied by 1 over 2, right? So it means multiplying 2 up here and multiplying 2 down here, right? Minus 1 upon 4, right? So if we do this math, we say 2 times 1, we will get 2. We say 2 times 2 going to get what? 4 minus we have 1 upon what? 4. Right? So we're noticing that the denominator are the same, right? So I'm going to take 1, which is 4, and subtract 1 from these 2, which is what? 1 upon 4. Right? We have 1 upon 4. Okay, so now we can rewrite it as 2 over 4 here. 2 upon 4 minus, here will be 1 over 4, will be 1 over 4, and our answer here going to be 1 over 4. This is it, right? 1 over 4. So this is the answer for this particular question. Now to show the representation of this particular question, we have this diagram, right? First, we say that in the first problem that we concluded, we can also use that conclusion to also estimate this, right? So we say this state diagram represents fraction. The first thing that comes into your mind, right? This particular diagram represents fraction, right? Okay, the next thing you say the numerator, which is 1, represent the shaded part. You see, we have one shaded part. Unlike here, right, we have 3, right? So because we're having numerator of 3, but here we have a numerator of 1, so we only have one shaded part, right? So the numerator of 1 represent the shaded part. Now the denominator 2 represent the total number of equal parts in the whole, right? I mean the entire diagram is what? 2. This is the proper and concise or precise representation of this particular diagram. So thank you very much. I will see you in our next lecture, which is lecture 5 and 6.